A thin, savory pancake enjoyed by millions. It seems simple enough, doesn't it? Well, look a little closer at these two. The British Crêpe soft, pliable and foldable, and the South Indian Dosa impossibly thin, brittle and shatteringly crisp. When the proteins in flour mix with water, they form long, elastic strands called gluten. The more you mix and knead, the longer these strands become. And when they're cooked, the gluten strands form a network that holds the structure together. Think of it like creating a microscopic, edible fabric. This gluten network forms a strong, flexible web throughout the batter. The texture of a crepe comes from a strong, flexible gluten network, like a woven fabric. In fact, if you put a lid on the pan, the dosa will cook evenly and more quickly. Here's why. The most common shape of a dosa is round, but the way it's made, it starts out as a spiral. So, the outer part of the spiral gets done first, then the inner part. Here's how you can make a perfectly round dosa. After you spread out your spiral, gently pull the edges inwards towards the middle, making sure the middle part is still a good distance from the hot pan. This way it has time to cook without burning. The texture of a dosa comes from a fragile, crispy lattice created by fermented air bubbles, like a delicate sponge. Remember, it's all about that brittle lattice. The force of folding is enough to snap the thin, delicate structure, but you can fix that. If you want to eat your dosa as a burrito, gently place the rolled dosa on a fresh spot on the pan, press down with a spatula, and let the delicate lattice relax and smooth itself out. Then continue cooking. One is designed to be strong and foldable. The other is designed to be light and to shatter. As it cooks, the structure sets, but it remains pliable and foldable. It has structural integrity. Food is just one example. We have made several videos about the physics of food already. You can find them all on our channel. They look so similar, yet their textures are polar opposites. The energy from the hot pan passes directly into the batter, creating a solid yet soft pancake that you can nicely fold around your favorite filling. In fact, I'm pretty sure I've tried both versions of the pancake in every country on earth. Which one do you prefer? Let us know in the comments below. Its biggest secret weapon is fermentation. 4 hours before cooking, this batter is left to ferment. The instant it hits the heat, those trapped carbon dioxide bubbles expand dramatically. They create a vast network of tiny, delicate pockets. Because the batter is so thin, the water in it turns to steam and evaporates almost instantly. What's left behind isn't a flexible web of gluten, but a brittle, fragile lattice of cooked batter, full of holes. That is the source of the incredible naturally occurring yeasts and bacteria get to work, consuming the starches and releasing millions of tiny bubbles of carbon dioxide gas. The batter literally becomes filled with air. It's the physics of strength and flexibility. How can two simple batters, cooked on a hot pan, end up so different? It's not magic. It's a masterclass in two very different kinds of physics. First up, the British Crêpe. The secret to its soft, chewy texture lies in one key ingredient: plain flour. The heat from the pan cooks the batter. All that's happening here is simple and now the dosa, its batter is typically made from rice and lentils, and crucially it contains almost no gluten. Now, watch the physics in action. The batter is spread incredibly thin on a very hot pan. So, here's the beautiful physics of it all. If you like your dosas extra crispy, you may notice that some parts of the dosa cook faster than others. You might also wonder why dosas often break into pieces when they're folded. Now, I'm a big fan of both of these dishes. There are lots of things in our everyday lives that might seem simple, but are actually science experiments waiting to happen. Thanks for watching.